All right. Also, these are available to you if you happen to. I know, like Tayshawn in in our other 7th grade class, he has it. He actually has a. I think he's got an iPhone, but he's actually got it saved on his iPhone, where you can go to my notes. Okay, so if you go to the notes, and you can actually read the QR code again, and it has all. Basically, the QR codes underneath these have these things I've already typed out. Okay, but if you happen to want to get them on your phone or whatever, you can. They're available there, just like all the other ones were, and then this one obviously down here has the 2 verses on it, and we'll talk about those here in a second. I did like one of the groups. One of the groups did understand. I don't remember which one it is. We'll talk about it here in a second, but they did comprehend what the verses meant along with the functions. Okay, but we need to talk about functions. Okay, once again, a function is a rule that relates to quantities. Okay, a function deals with input values called the domain and output values called the range. These can be expressed in a table. Okay, and one of the QR codes, we had 2 tables, and that was part of the problem, is to try to look at those 2 tables and see what the pattern was, which is basically the rule for functions. Okay, now functions can be expressed in the following form. Basically, here's how a function is going to be expressed. It's going to be y equal something. The something is going to have an x. Okay, now that something could be expressed as, for example, y equal 5x. Okay, or it could be y equal x minus 2.6. It could be y equal x squared. It could be y equal 2x plus 4. Okay, but whatever it is, and I'm going to show you examples of some of those here in a second. Whatever it is, it must be y equal and then something. It could be x plus 4. It could be x minus 4. It could just be x. Y is equal to x. Okay? But it has to be y, the output value on one side, is equal to the input value, which you're doing something to that input value. What I want to talk about, before we obviously, I'm going to go on down here past the memory verses. I'm not going to require you to put the memory verses in there. You might just put the references, Luke 6:45 and Matthew 12:35. I'm not going to require you to write that in there right now. Okay? Because we'll get back to those here in a second. But basically what a function is this. Think of it in these terms. I have a box. Whoa. It just went everywhere. Come on, give me that box. Okay. All right, I have a box. Okay. In this box, there is something happening. Okay, we don't know what's happening. All we know is this, is that when I plug in a number, for example 2, I plug in 2, it goes into the box, this is our input, and our output comes out 4. Okay, we don't know what happens to it. Several things could happen to it to make it come out 4. In other words, what's one thing I could do to 2 that would make it come out of 4? Drew, plus 2. Okay, what's something else I could do to 2 to make it come out to be a 4? Multiply by what? Yeah, multiply by 2. There's one other thing that I could do to 2 to make it come out to be a 4. Okay, what else could I do? We could divide it, but you would have to divide it by something that's a decimal, because obviously you can't divide 1 into 2 and get a whole number. So you'd have to divide a decimal. We could actually subtract a negative and get 4. Okay, well, let me add another number here, and let's see if it helps you understand maybe what we're doing. You put in 3, and it comes out 9. I put in a 4, and it comes out 16. So what are we doing? We're multiplying by itself, but how do you express that in mathematical terms? In other words, if I'm trying to come up with a rule that looks like this, y equal x, something's doing to x. How can I express that? Zach? X squared. Okay? So we are squaring the input value to come out with the output values we're coming out with. How do we write that as a function? That's one of the ones we had, the y equal x squared. So this is the function rule, okay, that's going on inside that box. Okay? That is the function rule that's going on inside that box. That's what's happening to the numbers for them to come out. Now, we could also express that, like we said, in a table. In other words, I have a table. I have my x, which is my input, and I have my y, which is my output. And then I have 2, and it's 4. I have 3, and it's 9. I have 4, and it's 16. So if I had 5, and the same rule applies, what is the 5 going to be? 25. Okay? So how they're going to do it in the book is they're going to give you a table. They're not going to draw a little box with arrows like I'm doing right there. They're going to give you an input-output table. Okay, that's what this is called. This is called an input-output table. Okay, where the inputs are the domain, the outputs are the range. There'll be problems where they say the domain of the function is this, what are the outputs, or what are the range? Okay, so they're going to use different terms, so make sure you understand that input is the domain, output is the range. Okay, the output of the data is the range. Now, let's look at something else. Let's look at this. Let's say I had an input-output table. And I'm just going to put X and Y. I'm not going to put X input, Y output. Okay, what if I put an A and a B there? What if it says A and B instead of X and Y? Which would be the input? A. First letter. B. Second letter is the output. Okay. Usually when you have input and outputs and they use different letters besides X and Y, it's in alphabetical order. So if they used M and N, M would be the input, N would be the output. Okay. Rarely ever have I seen them use like A and Z. But if they did, A would be the input, Z would be the output. Okay? And usually when you have an input-output table, the input's always in the first row, output's always in the second row. Okay? So if I did this, okay, if I did that, initially, most of you were going what? Y equal X plus 3. We're adding 3. But then what happened?
You got that 2 and 6.
Right. We got to the second 2, and now there's a 6. Okay? This is not a function. The reason it is not a function is because of these two things right here. A function must have exactly one output for each specific input. If I plug a 2 into this table, it would always, for it to be a true function, it would always have to either spit out a 5 or spit out a 6. It can't do both. A 2 can't be plugged into the table or the box and come out with a different output. Because a function rule holds that the same thing is happening to every single input. for a function rule to be true. Yeah, Nick?
So two of the same inputs have to have the same output.
Yes, every single time. Now, you can do this. In other words, it could look like this. A lot of times they'll show it like this. They'll put inputs here. Let's go 0, 2, 4, 6, 2, 8. And then outputs will be over here. And the outputs may be 5, 7, 9, 13. Okay? And then what they'll do is they'll draw lines to it. They'll go, okay, here, 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 here. Okay? Now, here's the point I'm trying to make. Several inputs can have the same number for an output. Okay? For example, if I was saying y is equal to 0 times x, then what are all your outputs? 0. But if I plug a 2 in and get 0 one time, then I'm going to plug a 2 in the next time, and I'm still going to get a what? A 0, correct? All right? So an input, two different inputs can have exactly the same output. But an input can't have two separate outputs that are different, okay, for it to be a true function. Functions are only going to have an input. Anytime I plug in a certain input, it has to have the same output every single time, or it's not a true function. Okay? So first of all, for us to know whether something's a true function, in other words, in our first example up here, in this example here, we have to assume that it is a true function. Is there any way we can tell whether or not this is a true function? Why?
Because there's, I don't know.
I mean, let me rephrase that. Is there any way we can tell that this is not a function?
No.
No. The reason being, are any of those inputs the same? No. So that's the first thing. To tell whether or not it is not a function, we would have to have two inputs that are the same. If we don't, then we have to assume it is a function. Okay, I have to assume this is a function. Now, if they put in another, if they put in another here and went like this and said 2 and that's 6, then obviously, okay, well, that's not a function. Okay, but they didn't, and so therefore we have to assume that it is a function. Okay? All right, now, let's talk about let's look at this input-output table and talk about this function rule. See if we can figure out what the rule is. All right, we have x and y. Ooh, terrible line. We have x and y, and then we have 2, 3, 4, and 5. And then we have 0.8, 1.8, 2.8, 3.8. Okay, and they want to know the function rule. Well, first of all, you need to understand input and outputs. For me to go from 2 to 0.8, I decreased the number. Okay? In mathematics, what are the two only ways that you can decrease the value of a number? Nick? Divide, division, and subtraction. So, I know right off the bat then, when I went from 2 to 0.8, that I'm subtracting, okay, or I'm dividing. Now, obviously, well, you can take plus and negative. Well, but what is plus and negative? Plus and negative is what? Subtraction. When I take 2 minus 3, 2 plus negative 3 is the same thing, correct? Okay. So plus and negative is the same thing as subtraction, so don't get technical on me. Well, you can add. you're adding a negative, which is the same thing as subtracting. Okay? So, what did I do to 2 to take it to 0.8? What did I do? In other words, I had 2 is on this side, and 0.8 is on this side. 0.8 is on this side, okay? And 2 is on this side, and I subtracted it from something. What did I subtract from 2 to get 0.8, Drew? 1.2. I subtracted 2 minus 1.2 is equal to 0.8. Now, I'm not done, okay? Because just like we talked about a while ago when we had the 2 that went in the box and came out 4, okay, and we had 3 different things you could have done to it, we need to check this to make sure this is really the true rule. So then what we do is we take 3 minus 1.2. Okay, 3 minus 1.2 is 1.8. We take 4 minus 1.2, and that is 2.8. And we take 5 minus 1.2, and that is 3.8. So it does all of these check with these. Okay, all of our outputs actually work. So the rule then for this input-output table is y is equal to the input x minus 1.2. And that's your function rule for that input-output table. Now, the way they do it in the directions, they say, it says write a function rule for the input-output table. Okay, so that's how you write a function rule for the input-output table. Now, let's look at this. Let's say they give us a function rule, y equal to x plus 11. They give us this function rule, and they want to know the range. What is the range equal to if the domain equals -2, -1, 0, 1, and 2? Okay, they want to know what the range is if our domain is -2, -1, 0, 1, and 2. Well, unfortunately, what they want you to do is take y equal the first domain, -2 plus 11. What is -2 plus 11? 9. So y is equal to 9. So that's your first range. Then they want you to take and plug in -1 plus 11. Y is equal to 10. Then they want you to plug in y is equal to 0 plus 11. 11. Okay, now they want you to plug in y is equal to 1 plus 11, which is 12. And then they want you to go y is equal to 2 plus 11, which is 13. So there's your range. 9, 10, 11, 12, and 13. Okay? You could have plugged that into an input-output table. You could add your little input-output table like this. Have your x and your y, and then you have -2, -1, 0, 1, 2. Okay, and then you could have said, okay, well, that's 9. And you see the pattern. Once you develop the pattern, you can just, fill it in. Okay, but that's the work you're doing either in your head or on the paper to get the range. Okay, and then you need to list the range out. Okay, so what if they had this? Y is equal to 0.8x minus 1. Okay, they want you to do the same thing. So we plug in y is equal to 0.8 times -2 minus 1. Okay, Okay, well, what is 0.8 times 2? 1.6. So y is equal to 1.6 minus 1. But that is negative 1.6. So that is y equal negative 1.6 plus negative 1, which is negative 2.6. That's your first answer. A little harder, maybe harder to do in your head. Then we take and we go y is equal to 0.8 times negative 1 minus 1. Well, that's y is equal to negative 0.8 minus 1. Y is equal to negative 0.8 plus negative 1. So y is equal to negative 1.8.
Okay.
Yeah.
So y equals 0.8 minus 1. How do we get to negative 2?
That's your domain values. They're going to give you a set of values for like 6 different problems. So they're going to say, this is your domain, this is your input values, and we're going to use it on all 6 of these problems. Okay? And that's what they'll do in the directions. Okay? Now, you get down here and you say, okay, y is equal to 0.8 times 0 minus 1. Well, that's y is equal to 0 minus 1, which is
No, you can't do that.
negative negative 1, because this is 0 plus negative 1. So then you have y equal 0.8 times 1 minus 1. That's y is equal to 0.8 minus 1, which is y is equal to 0.8 plus negative 1. So y is equal to negative 0.2. And then the last one is y is equal to 0.8 times 2 minus 1. That's y is equal to 1.6 minus 1. That's y is equal to 1.6 plus negative 1. So y is equal to 0.6. Okay, so your domain for that one, or your range for that one, was negative 2.6. Negative 1 was negative 1.8. Negative 0.2. Nope. Where's my 0? There it is. Negative 1, negative 0.2, and 0.6. That's your range. That one's a little harder, obviously, because you're multiplying decimals and you're having to deal with the negatives and positives both. Okay, but the pattern's still there. Okay, the pattern's still there. You're decreasing it by 0.8 each time. Okay, now, so that's how you use the domain and find the range. That's how we have an input-output table and find the rule. Okay, now, as we look back up here at our verses, Luke 6:45 says, a good man brings good things out of good stored up in his heart. Okay? An evil man brings evil things out of the evil stored up in his heart. For the mouth speaks what the heart is full of. Okay? So here, the heart is the input. And the mouth, which some of us have issues with, is the output. Okay? So the input is the heart, what we put into our heart, And a lot of times, because basically here's how it works. What you see with your eyes, okay, goes to the brain, and the brain interprets it into the heart. Okay? So if you're, for example, if you're around a bunch of friends, and I can attest to this, okay, my dad was a pastor for most of my life, okay, since I was in first or second grade. Okay, since I was 7 years old, my dad's been a pastor or a missionary. Okay, when I was in high school, I worked at a place where there wasn't any Christians. It was in manufacturing. It was a warehouse and a manufacturing plant, and the guys there weren't Christians. And every day I was surrounded by guys using every sorts of bad language that there is, using God's name in vain. Every cuss word there was, I heard it on a daily basis.
What was the place called?
Huh? It's called Professional Metal Finishers. We basically chrome-plated bumpers, we gold-plated jewelry. It wasn't a bad place to work. It was just the people there weren't Christians. Okay? So what happened is, as I sat around that stuff more and more, okay, I started using some of the same language they started using. Now, I didn't start using it around my parents, because I knew what my dad would do to me if he ever heard that kind of language out of my mouth. Okay? But it was one of these deals is what you put yourself around eventually is going to flow from your mouth or from your actions. Okay? When you get so in tune and you're so just numb to it, okay, because that's what starts happening. I didn't go to a Christian school, so kids at my school, just like, some of the kids sneak around here and do, use bad language. They'd go out and do bad things. And so when you put yourself around that, eventually, whether it's going through your eyes or through your ears, your eyes and your ears are the filter to your soul. Okay? The more and more you get around that stuff, the more and more that stuff is going to come out of you. Okay? It's just like a person that has problems with alcohol. Is it best to go sit in a bar? Well, probably not. Okay, just like a person that has trouble smoking. Well, is it best to have a pack of cigarettes right next to you all the time if you're trying to quit? No. Person that has problems with eating, they eat too much. Okay? Well, is it best to have a chocolate cake sitting in your kitchen if you're trying to be on a diet? People that are on a diet, you don't want to have ice cream and cookies and all that stuff sitting in a house, because then it takes more willpower. Okay? All right, so what we're talking about is what we input into our souls is eventually going to come to the outside. Okay, just like a person that maybe cusses on the side, not when they're around their Christian friends or around their Christian adults, eventually it's going to come out, and that's going to come out eventually. Okay? So what we feel, and that's why God is so in detail about what you should be putting into your mind. That's why you should be reading your Bible daily. That's why you should be praying daily. That's why, because as those things are going into you, then those things will also flow out of you. Okay? So that's what this is talking about. So the heart that has good being put into it, obviously the output is good. The Bible says that. The one that has evil in it is going to produce evil. Okay? And this is Matthew 12:35 is just another way to say it. A good man brings good things out of good stored up in him, and an evil man brings out evil things out of the evil stored up in him. Whatever you're putting inside of you, that is what is going to come out, either in your actions, in your speech, or sometimes just in your thoughts. And you go, well, I just thought that. The Bible says that if you have hatred toward your brother, if you think about murder, you've basically done it. So the mind thinks, it's basically because why? Well, because really the only person that knows our thoughts are ourselves and God. Okay? So what you think is still sin. Now, it may not be followed with a physical action. You know, you go, well, I'd love to have my next door neighbor's Porsche. Okay? Well, one of the 10 Commandments is don't covet your neighbor. Possessions. Don't covet your neighbor in any way. Okay? So, what you plug into yourself is going to come out. Okay? So, it's an input-output situation. Input good things, input the Word of God is going to come out. Input going to church and influencing your friends in a godly way, those things are going to come out of you. Okay? So, it helps to have who you hang around with, what they do. Now, nobody's perfect. So every person you hang around is going to have some type of sin in their lives. Maybe visible sin, maybe non-visible. In other words, they may be doing things behind closed doors that is not real pleasing to God, but eventually their actions will say it. Now, back to my story, I end up quitting the job simply because the Lord shook me one day and got a hold of me and said, how can you be 100% on fire for me if you're around this 80% of your life? If you're in the pond and the pond is full of mud and scum, then eventually you're going to come out looking like mud and scum. Okay? And so we don't need to do that. So I went in, told the guy I needed to quit, and he didn't like it because I was a hard worker and I was doing a good job. And he's like, well, what can I do to keep you? I said, well, it's something the Lord's told me to do. And he heard that and he was like, oh, okay. All right, man, appreciate it. He didn't want to hear the Lord thing. And so there's been times that I've had to, in my life, I've had to separate. I had a real good friend in high school. I was a year ahead of him, and he was a senior. I'd already been out, and we were real good friends. But he was doing stuff his senior year that, my parents didn't approve of, and I didn't either. He was going to parties, drinking, doing a bunch of different stuff, and my parents came to me and said, if you're going to continue to be friends with him, then he has to exhibit a godly behavior, a godly character. And I went to him, and I basically told him, I said, we're going to still be friends, but if we're going to be friends that hang out, do all this stuff together, then you're going to have to quit. And I just went and detailed this, and this, because that's not pleasing to God, doesn't bring a good reputation or a good outward appearance to others, and it doesn't to me as well. Well, unfortunately for him, he decided that he wanted to keep doing that. And unfortunately for him, he made some choices after that weren't real good. And he came to me about 3 or 4 years later. He called me up and said, hey, can we get together? And I said, sure, let's have lunch. And so we had lunch. He was here in Fort Worth. I'd actually moved back to Fort Worth at that point. And he sat there in front of me and cried real bad, just for about 30 minutes, and just all the things he had done. He was now sitting there as a 22-year-old kid, married with 2 kids, in a dead-end job, just simply because of some of the choices he made. And, I told him what he needed to do to make, to help his life get back on track and be on the plan God had for him. And he just wasn't really willing to do that. And last time, I haven't heard from him in a long time, but I know some people that know him, and, he was still, I think he's been divorced a couple of times now, and so the things and the people that you put around yourselves will affect the input you put into your life will eventually come out. Okay? So make sure you're putting good input in. Reading the Word of God, not just because it's assigned in a class. Okay? Praying, lifting others up, lifting burdens other people have up. Lifting those burdens to the Lord. Pray for others. Okay? So that's what we're talking about when we're talking about input and output. That's our functions. That's our function rule. Okay? just like our function rule is, you can't get one input in and get a different output. Okay, if you sow into your mind people cussing all the time, you're not going to get out a different output. Eventually it's going to come out that way. Okay, so make sure what you're inputting into your life and in our mathematics is coming out with the same output. Okay, your homework is this. I'm going to sort of cut down in the sense of, because I know there's a lot of steps on several of them. So here's what we're going to do. Let me get down here to the bottom. We're doing 7.7. We're going to do 9 through 14 even. So you're going to start with 10, obviously. And then you're going to do 15 through 26. 15 through 26 is all. Okay, let's do tomorrow. You may go.